Well, we are now in section 2, the double digit integer section. Question 7 says, if distance covered by a particle executing SHM with time period 24 seconds and amplitude A in time 2 seconds, starting from rest is A by 2 within brackets n minus under root n plus 1, then value of 6n is equal to. Well, it's a simple question on simple harmonic motion. We have to find the distance traveled in time 2 seconds and then evaluate the value of n. Since the particle is starting from rest, we can write its equation as x equals a cos omega t. Now since time period is given, so omega is 2 pi upon t, that means 2 pi upon 24 or pi by 12 radian per second. So that means we can write the equation x equals a cos pi by 12 t. So the value of x at t equal to 0 is a. Let's call it x1. x1 is the value of x at t equal to 0 and that is equal to a. And the value of x at t equal to 2 seconds, let's call it x2, is a cos pi by 12 into t, which is 2. That means it is a cos pi by 6. And that means this is root 3a upon 2. So the distance travelled equals a minus a root 3 by 2, or it's equal to a by 2 into 2 minus root 3. Let us compare this with a by 2 into n minus under root n plus 1. It's very clear that the value of n is 2 and that means the value of 6n, which is being asked in the question, is 12. So our answer for question 7 is 12. Very simple, isn't it? Let's move on to the next question now. Question 8 says, a small electric car has a maximum constant acceleration of 1 meter per second square, a maximum constant deceleration of 2 meter per second square, and a maximum speed of 20 meter per second. The minimum time in seconds it would take to drive this car 1 kilometer starting from rest and finishing at rest is. Well, the question belongs to the section kinematics. To solve, let us draw its velocity versus time graph for the minimum time for covering 1 kilometer. Okay. So the graph will look like this. This is velocity and this is, let's say, time. The maximum speed is 20 meter per second and the maximum acceleration it can have is 1 meter per second square. So if it accelerates with 1 meter per second square, it will reach the velocity of 20 meter per second in 20 seconds. That means for first 20 seconds, the graph is something like this. This value is 20 meter per second. And let's say for some time it moves with uniform velocity of 20 meter per second and then it decelerates to rest. Since magnitude of maximum deceleration is twice the magnitude of maximum acceleration, it will take half the time to come to rest. That means this time interval is only 10 seconds, right? Now the displacement is 1000 meters, which equals the area of this graph, of this trapezium. So the equation is 1000 meter equals area of this triangle, which is 1 by 2 into 20 into 20, plus area of the other triangle, which is half into 10 into 20, and plus area of the rectangle. So if the total time is t second, the length of the rectangle is t minus 30 second, because 20 second and 10 second have been taken up here. So the length of the rectangle is t minus 30 second. So the area is T minus 30 into 20 or 20 into T minus 30. Let us solve. The right hand side equals, this is 200 and this is 100, this is 300 plus 20T minus 600 this is 20T minus 300. Solving we get T equals 1300 divided by 20 or 65 seconds. Pretty simple, isn't it? So the answer to question 8 is 65. Let's move on to the next question now. Question 9 says, two identical ladders, each of mass capital M equals 1 kg, are arranged at right angle in a vertical plane. A force F is applied vertically downward at their common point as shown. If complete arrangement is in equilibrium and frictional force on each ladder from horizontal surface is 10 Newton, then magnitude of force F in Newton is equal to. Well, the question belongs to the section System of Particles and Rotation. It's a case of equilibrium of a rigid body where the net force is 0 and the net torque is also 0. So we draw the free body diagram first. The forces are, there is force F here, whose magnitude we have to find. There will be weight of the left ladder, which is mg or 10 Newton. There is normal reaction here. Let's say it is N1. And there is friction whose magnitude is 10 Newton. Similarly, on the right ladder, its weight is mg equal to 10 Newton. There is normal reaction here. By symmetry, this is also N1. And there is frictional force F equal to 10 Newton as stated in the problem. Let's call this point A. Now, for translational equilibrium, it's very clear that 2N1 in vertically upward direction equals 2mg plus F, or that means N1 equals mg plus F by 2 or 10 Newton plus F by 2. Let's now talk about this point A, and let's look at rotational equilibrium of the left ladder. That being the case, we have in the clockwise sense there will be torque of N1, and in the anti-clockwise sense there is torque of friction and mg. So if the length is L, then the torque of friction in the anti-clockwise sense equals, and we are putting torque about A equal to 0, which is giving us, so the anti-clockwise torque is 10 L by root 2 in SI units plus 10 L by 2 root 2 minus the torque in the clockwise sense is 10 plus F by 2 into L by root 2, and this equals 0. So if I remove L by root 2 everywhere, what we get is 10 plus 5, 15 minus 10, that means 5 minus F by 2 equals 0, or F equals 10 Newton. That means answer to question 9 is 10. Let's now move on to the next question. Question 10 says, two right angle triangular plates ABC and X having masses 6 kg and 3 kg respectively are arranged as shown in figure. Moment of inertia in SI units about axis PQ is equal to? Well, it's a pretty simple question on finding moment of inertia. We know a uniform triangular plate, moment of inertia is given by the expression I equals mh square by 6. We can use the same expression here. So applying this formula, the moment of inertia I will be sum of the moment of inertia of the two triangles. This equals, for triangle 1, this is the axis, so h will be 4 meter, and for the other triangle h will be 8 meter. So I1 equals 3 into 4 square by 6, and for the other plate it is 6 into 8 square upon 6. 48 plus 6 into 64. Let's simplify it further. It's 48 plus 6 4s are 24, 4 carry is 2 is 38 by 6. Simplifying this value comes out to 72 SI units. So our answer to question 10 is 72. Let's now go to the next question. Question 11 says block B starts from rest and accelerates as AB equals 12t meter per second square. Simultaneously, other end of the string is pulled with constant acceleration A0. If at t equal to 3 seconds, block A comes to rest, then value of A0 in meter per second square is equal to. Well, this is a question from the constant relation. Let's apply the constant relation. Let's assume that block is moving down with acceleration A. Let's apply the constant relation. We get t into 12t, the tension here is t, minus 2t into A equals minus t into A0 equals 0. This means 12t minus 2A minus A0 equals 0, or A equals 6t minus A0 by 2. That means we can further write dV by dt equals 6t minus A0 by 2, or dV equals 6t minus A0 by 2 dt. So the left hand side, the limits will be 0 and 0 because it starts from rest and comes to rest again. T goes from 0 to t. Solving, we get 0 equals 6t square by 2 minus A0 by 2t. Putting t equal to 3 seconds, we get 3 into 3 square equals A0 3 by 2. That means A0 equals 18 meter per second square. So answer to question 11 is 18. Let's now go to the next question. Well, question 12 says a cylindrical vessel fixed over a triangular wedge is filled with a liquid and made to accelerate along a fixed smooth inclined plane under the action of force F equal to 600 Newton up the inclined plane. If combined mass of accelerated system is 50 kg, then angle made by free surface of liquid from horizontal is equal to tan inverse 6 by n. Then find n. Well, the question is from the section mechanical properties of liquids, and it's a case of accelerated container containing a liquid. Let's first find the acceleration of the entire system. To find the acceleration of the entire system, we just draw its free body diagram, and the mass is 50 kg. So there is this 50 g or 500 Newton. Then there is this force of 600 Newton. If we resolve this 500 Newton, this angle is 37 degree. So this angle is also 37 degree. And so this component is 500 sine 37 degree. And let's say acceleration is A along the incline. Then we have 600 minus 500 sine 37 degree, which is 3 by 5, equals 50A. If we solve it further, we get A equal to 6 meter per second square. Now let's consider that the liquid surface makes angle theta with the horizontal. So let's say this is the horizontal and the liquid surface makes angle theta with this horizontal, and this is the incline. So this is, we are considering the surface of the liquid. This angle is 37 degree. This angle is also 37 degree. Now the idea here is that if we consider a particle on the surface of liquid of mass m, then the resultant of pseudo force and mg on this particle is perpendicular to the surface, right? So there is no component. If we consider these two forces, the pseudo force and mg, their resultant along the surface will be 0. Whatever the resultant, it will only be on the normal to the surface. So that means if I draw FBD of this particle, we take a pseudo force, which is, since the acceleration is 6 meter per second square up the incline, so there is this pseudo force along the incline in the downward direction, m into 6. There is this force m into g, and as I said, the resultant of these two forces along the surface of liquid will be 0, which means we have the equation now. This angle is 90 degree minus theta, so it means mg cos 90 degree minus theta or mg sin theta equals component of this force along this incline. Now if we draw these angles, this angle is also 37 degree. This angle is theta, and this angle is also 37 degree, which means mg sin theta equals m into 6 into cos theta plus 37 degree. Solving, we get 10 sin theta, m gets cancelled on both sides, equals 6 into cos theta cos 37 degree, which is cos theta into 4 by 5, minus sin theta sin 37 degree, which is minus sin theta into 3 by 5. Solving further, we get it as tan theta equals 6 by 17, and that means theta is tan inverse of 6 by 17, which means n is 17. So our answer to this question is n equals 17. Let's now go to the next question. Question 13 says, a horizontally oriented tube AB filled with an ideal liquid of density 1 gram per ml of length L equal to root 8 meter rotates with a constant angular velocity omega equal to 10 radian per second about a vertical axis. If pressure at end B is n into 10 to the power n plus 2 NSI units, then value of n is equal to, take pressure in the empty part of the tube to be 0. Here we will involve concepts of fluids and of course the circular motion. So what we do is, we take an element of liquid of length dx and add distance x from the axis. So this part has length dx, and we consider motion of this element of the liquid. Now on this liquid, if the pressure is P at distance x, so that means the force is P into area, and here the pressure is P plus dP, so here the force is P plus dP into area of cross section. So that means the net force is dP into A. So we can write the equation now. Net force dP into A on that liquid, on that element of liquid, equals its mass. Its mass will be equal to A dx into rho, mass omega square into x. Now we can cancel A on both sides. We have got expression for dP. So if we integrate now, integrate both sides, here we get rho omega square x dx. Integrate this side too. The limit of P here goes from 0 to pressure at point B, and x goes from L by 2 to L. Integrating, we get PB equals rho omega square by 2 into x square, and if we put the limit, it is L square minus L by 2 whole square. Solving it further and putting the values, rho here is 10 to the power 3 in SI units, so we get it as 10 to the power 3. Omega square is 100 by 2 into 3 by 4 L square, and the value of L square is 8 SI units. So solving it, we get it as 3 into 10 to the power 5 Pascal. If we compare this with the expression given in the question, we put it as this pressure is equal to N into 10 to the power N plus 2. It's very clear that the value of N is 3. So our answer to this question now is 03. Let's now move on to the next question. Question 14 says, a light wire having Young's modulus Y and radius R stretched without tension along a straight line AB is fixed at A and B. A force F is applied at the midpoint of the wire, due to which the wire is pulled into the shape ACB. The depression D in the wire in centimeter is equal to, given F upon pi r square Y equals 10 to the power minus 6 by 27 in SI units, and L equals 8100 centimeter. We have to find this D. This question is from the section Mechanical Properties of Solids, that is elasticity, and let's draw FBD of point C. If we do that, at point C we get, suppose this angle is taken as theta, so tension here is T and here also it is T. We can see that this angle is also theta, so 2T sine theta equals F, or tension in the wire is T, which is F upon 2 sine theta. Now this length is L, half the wire has length L, and this has become L plus delta L. Let's apply the Pythagoras theorem and we get L plus delta L the whole square equals L square plus D square. Simplifying, we get L square plus 2L delta L plus delta L whole square equals L square plus D square. We cancel L square on both sides, and since delta L is going to be small, so delta L square can be neglected. This gives us D square equals 2L delta L. Further, the expression for delta L is tension upon area of cross section A into the length L, original length L, and in the denominator you have Y here, right? So which can further be put as F by 2 sine theta L by pi r square into Y, and the sine theta itself can be written as F upon pi r square Y, and then there is L here and there is 2. Sine theta can be written as D upon L plus delta L, but then delta L can be neglected here at this place, So that means if we combine this expression with this expression, we get d square equals 2l into fl square by 2 times pi r square y into d, or dq equals fl cube by pi r square into y, right? So further simplifying, expression for d turns out to be equal to L into f upon pi r square y raised to the power 1 by 3. Let's put the values. L is 8100 centimeter and f by pi r square y has the value 10 to the power minus 6 by 27, which is 3q to the power 1 by 3. This equals 8100 into 10 to the power minus 2 upon 3, which again equals 27. So our answer to question 14 is 27. Let's now move on to the next question.